Hi, this is Teacher Layla again. So for this video, I will discuss to you about the permutation. So what is a permutation? Permutation is an arrangement of objects in a specific order. So the arrangement or the order of the objects in a permutation is very important. Suppose that we have three pictures labeled A, B, and C. So we are to arrange these three on the wall. The permutation of three paintings or different arrangement is shown. We have ABC, BAC, CAB, ACB, BCA, and CBA. Okay, observe that in each permutation, there are three pictures or the three pictures are there, diba? Contains the three pictures. Diba our pictures labeled A, B, and C? And in each permutation, there all contains the three pictures. So there are how many arrangement or how many permutations that we have? We have 6 arrangement. And this can be obtained using the fundamental rule by getting the product. Since we have three pictures, so we are going to multiply 3 times 2 times 1 is equals to 6. So if there are 4 pictures labeled Q, R, S, and T, how many ways can they arrange themselves? So since there are 4 pictures, we labeled QRST. So it is 4 times 3 times 2 times 1 is equals to 24. And the 4 pictures can arrange themselves in 24 ways. So the number of arrangement of 4 pictures is the permutation of 4 pictures or any object taken all at a time. Or in symbol, we have the permutation of 4 taken all at a time or taken 4 at a time. Because we have 4 pictures man, diba? And we take all the 4. That's why we have the permutation of 4 taken all at a time, which is equals to 24. Or that is 4 factorial. This is another the solution for 4 factorial. 4 times 3 times 2 times 1 or 4 factorial is equals to 24. So the factorial of a natural number n written as n factorial, or the permutation of a natural number taken all at a time written as n factorial, or n times n minus 1 times n minus 2 times n minus 3, and so on. So let's evaluate here. We have the permutation of 5 taken 5 at a time, or 5 factorial. The solution is 5 times 4 times 3 times 2 times 1 is equals to 120. Next, we have the permutation of 6 taken 6 at a time, or 6 factorial. The solution is 6 times 5 times 4 times 3 times 2 times 1 is equals to 720. Next, we have the 10 factorial, or the permutation of 10 taken all at a time. We have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equals to 3,628,800. So that is the permutation of an object taken all at a time. This is the formula. Then we have here the permutation of an object taken all at a time. This is denoted by permutation of n taken r at a time is equals to n factorial divided by n minus r factorial. Okay, this is the formula when we are going to take an object at a time. So let's evaluate. Example, we have the permutation of 9 taken 4 at a time. So our n is 9. So we have 9 factorial divided by the n is 9 minus r. We take 4 at a time man. That's why 9 minus 4 is equals to 5. Then factorial. So we have now 9 factorial is equals to 362,880. And then 5 factorial is equals to 120. So we are going to divide 362,880 divided by 120. That is equals to 3,024. Next example. The permutation of 12 taken 6 at a time. Again, our n here is 12. So we have 12 factorial divided by the difference of 12 and taken 6 at a time. We have 6 factorial. So 12 factorial divided by 6 factorial, that is equals to 665,280. Because 12 factorial is 479,001,600 and 6 factorial is 720. Then we divide that the quotient is 665,280. Next, the permutation of n objects where n sub 1 is of one kind, n sub 2 is of a second kind, and n sub k is of a kth kind is given by this. We have n factorial divided by the n sub 1 factorial times n sub 2 factorial times n sub 3 factorial and so on, and n sub k factorial, where n is equals to n sub 1 plus n sub 2 plus n sub 3 and so on. So I have here an example. The number of distinct permutation of the letters in the word sit, sirit, sit. So we are going to find the permutation of this word sit, sirit, sit. How many ways we can arrange this? Since there are, this is there, not n. Since there are 3s, okay, let's count 1, 2, 3. So we have 3s and 1, 2, 3, 4. We have 4i, then 3t, and 1r. So we have, okay, our n here, or the numerator, is the total or the number of characters in the word. Sit, sirit, sit have many characters. They have 11 characters. So that's why our n is 11 and we write n here. Then our denominator, since we have 3s, so we are going to put 3 factorial times the 4i, 4 factorial, times the 3t, 3 factorial, times 1r, 1 factorial. So 11 factorial equals 39,916,800, and 3 factorial times 4 factorial times 3 factorial times 1 factorial is equals to 864. Then we are going to divide this 39,916,800 divided by 864, that is equals to 46,200. Okay, next example. How many distinct permutations are there in a word mathematics? Okay, how many words are there? How many letters are there in a word mathematics? Okay, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 characters. So let's count how many m? 2m, 2a, 2t, 1h, 1e, 1i, 1c, and 1s. Okay, let's total 2, 4, 6, 7, 8, 9, 10, 11. Okay, so there are 11 characters. So our n is 11. That's why we have 11 factorial at the numerator. And the denominator, we have 2 factorial times 2 factorial times 2 factorial times 1 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 factorial is equals to 4,989,600. Okay. Next. Okay, the number of permutations of n objects in a circle. What if the permutation in an object of a circle? We're talking about circle, circular. So this is n minus 1 factorial. Always remember sa formula in different permutation of an object taken at a time, taken all at a time, and okay. So example, if 8 people are to occupy 8 seats around a table, how many different arrangements are possible? Again, if 8 people are to occupy 8 seats around a table, how many different arrangements are possible? Table is a round one, diba? There in the given. So this is the permutation of an object in a circle. So the formula is n minus 1 factorial. So since we have 8 people in the given, our n is 8. So we have n minus 1 or 8 minus 1 factorial. We have 7 factorial. And 7 factorial, that is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. So that is equals to 5,040. So there are 5,040 ways. Next. Okay, we have now an activities. A group, number 1, a group of 16 people must select a president, a vice president, a secretary, a treasurer, and an auditor. So in how many ways can this be done? Again, there are 16 people, no? So our n here is 16. So we are going to take a president, a vice president, a secretary, a treasurer, and an auditor. Okay, how many are there that must select? There are 5, diba? So we are going to select 5. That's why n minus r, we take 5. 16 minus 5 is equals to 11. So that is 16 factorial divided by the 11 factorial is equals to 54,160. So there are 54,160 ways. Or that is the permutation of 16 taken 5 at a time. Next, number 2. In how many ways can 2 children and 5 adults be seated in a row if the children must be seated at opposite ends of the row? So, in how many ways if there are 2 children and 5 adults taken all at a time man? So we have 2 factorial and 5 factorial. What will we do to this koan man? 2 children and 2 adults. The given. We are going to multiply this. So that is 2 factorial times 5 factorial is equals to 2 times 120. 2 factorial is 2 and 5 factorial is 120. So that is 2 times 120 is equals to 240. Next. Number 3. Maggie wants to change her Facebook password, Maggie08, but with the same letters and numbers. In how many ways can she do it? Okay, so let us find how many ways can Maggie change her Facebook password with the same letters and numbers. Maggie08. So Maggie08 have 8 characters, diba? So our n is 8 characters and we have 1m, that's why you have 1 factorial. 1a, that's why we have here times 1 factorial, times 2g, 2 factorial, times 1i, 1 factorial, times e, 1 factorial, times 0, 1 factorial, and times 8, 1 factorial. So our 8 factorial is equals to 43,200. And here, when we multiply, is equals to 2. Then we are going to divide, that is equals to 1,260. So Maggie can change her Facebook password with the same letters and numbers in 1,260 ways. Okay, next, number 4. In how many ways can an event organizer seat 9 guests around a table? Okay, it's round table. So what is the formula to? Okay, so we have 9 guests. So that is our n is 9, then minus 1. 9 minus 1 factorial, that is 8 factorial. And 8 factorial is equals to 40,320. Okay. That's all for our activities. So I have here additional information or the shortcut method for permutation with your calculator. If you have your calculator or your scientific calculator, how to input factorial to your calculator? The scientific calculator, ha? So example, 12 factorial. You are going to press in your calculator 12, then shift and this sign, x with the -1 exponent. That is, when you are going to press shift and this sign, x to the power of -1, that is equals to factorial. Ang mugawas kay factorial. So, 12 factorial equals 479,001,600. Then for permutation, typo error, kuwangag n. P. So, permutation of 5 taken 2 at a time. You are going to press 5, then shift X. Shift X in your calculator, ang mugawas is P. Then press 2. That is equals to 20. And anyway, students, in your activities, I am just showing you how to use the shortcut method for permutation with your calculator. But in your activities, please show your solution, ha? Show your solution in your activities. Do not use the shortcut method nga like this lang. Okay? I want to show the solution. The solution good. Like this. Okay? So, that's all for this video. Thank you so much for watching. God bless you all.